Hello everyone, my name is Minjung Kim. I'm a PhD student at Yonsei University in Seoul, Korea. I'm glad to present my paper, Feature Disentanglement Learning with Switching and Aggregation for Video-Based Person Re-Identification. Let me begin with the concept of video re-ID. Video re-ID aims at matching ID of specific person in multiple cameras with non-overlapping domains. In the test process, when the video of the target person is given, the network finds the same person in the video set called gallery. Most methods obtain one final embedding by utilizing spatial and temporal information. But this method uses such information without removing the distractor, which causes the intertwined features. Let's look at the figure. As the time interval between frames is small, a similar background is repeated. So the network frequently learns the background as a key feature as in the activation map like dashed box areas. As the final embedding includes the semantics of brief syntaxes, the network retrieves the video with different ID and similar background to the query video. This problem happens because the previous method extracts one final feature intertwined with not only ID information but also background information. So we came up with an idea to make final features resistant to the background information by disentangling features into ID features and camera features. This is our network design. DSANet involves three processes: feature disentangling, ID representation learning, and auxiliary task. DSANet separates features into ID features and camera features. Then ID representation learning performs ID features to become more resistant to changes in target's position through TLM and FWG. Finally, DSANet conducts auxiliary tasks by SAO, which augments features to have various camera characteristics. The series of processes learn end-to-end, and each component works cooperatively to extract robust and differential features. DSANet's components are most effective when used together, and perform best when all frames corresponding to the sequence are input. On 3 video re-ID datasets, our proposed method obtains reasonable performance with a lightweight network. In Figure 6, we visualize the heat map of each feature map. Figure 7 utilizes DSANet to demonstrate that each feature contains either the identity or the camera characteristics. This figure shows the results of retrieval. DSANet can completely focus on identity information because the characteristics of the captured camera are perfectly disentangled. Thank you for your attention.